Amundsen, Scott and Shackleton headed to Antarctica in search of adventure and the South Pole. The men and women who go there today encounter conditions just as difficult as those early trailblazers, but what they seek could have implications for us all. I met Dr. Robert Mulvaney, glaciologist at the British Antarctic Survey, to understand why Antarctica is so important to science.
Antarctica itself is a very critical part of the global climate system, so we do need to do research in Antarctica because it's just so critical to how our climate works. You get no melting in the polar regions and therefore the ice builds up year upon year upon year. As snow falls through the atmosphere, it collects all the material in the atmosphere, it collects some of the gases, it collects any aerosol in the atmosphere, but it also has some memory of the climate as well. So as the ice settles and gets compacted, it's remembering the climate and the atmosphere of the past. So by drilling into the ice, I'm able to drill back into the past and recreate what the climate and the atmosphere was doing through many thousands of years. Well, what we do is we take the water itself. So we take the ice, which is made up of water. Water is made up of hydrogen and oxygen molecules, H2O. And there are heavy and light isotopes of oxygen and heavy and light isotopes of hydrogen. Now, all the water that falls in central Antarctica comes from the surrounding oceans. It takes more energy to evaporate a heavy isotopic molecule from the ocean than it does a light isotope. So all we do in the lab here is we measure the ratio of the heavy to light isotopes of water, and where we see proportionately more of the heavy isotope, we know the climate must have been warmer. So all we're doing is measuring this ratio of heavy to light isotopes of the oxygen and hydrogen from water and relating those to temperature. And by doing that through time, we can build up a climate record. So that's where our climate comes from. In central Antarctica, there's about this much snowfall per year. So if we go down a few hundred metres, we're going back a few thousand years. If we go all the way down to the bed, because the layers get thinner and thinner and thinner as you get closer to the bottom, we're going back hundreds of thousands of years. And in central Antarctica, I was involved in a big project, a place called Dome C, where we drilled all the way through to the bed, 3,200 metres down, and that gave us 800,000 years of climate and atmosphere record.
So research in Antarctica can tell us about historical temperatures on the planet. But how is that useful to us today?
About 10% of the volume of a deep ice core is air. So we're able to take a piece of ice from the past, we put it in an enclosed container, we suck out all the modern air to create a vacuum, and then we release the air by crushing the ice inside that container. Once that air's out, we're able to measure it in our instruments, and we can measure what was actually in the atmosphere at any point in the past.
This ice, the area of this ice that we're looking at right now, was floating around in the atmosphere at the time of the Battle of Hastings.
Yes, so they would have been breathing air with this level of carbon dioxide. In fact, they would have they would have been breathing this actual air. This is the real air.
So if we look at that record, over all that period of time, we can see a very close correlation between carbon dioxide and temperature. Now, all through that period of time, the lowest levels of carbon dioxide we see in the atmosphere are 180 parts per million. That's 180 molecules in every million molecules of air. And in a warm period, we see up to 280 parts per million. Today, we're close on 400 parts per million, so 120 parts per million higher than at any point we've seen in the last 800,000 years. Now, that increase began about 250 years ago at the beginning of the Industrial Revolution.
So Antarctica has been essential in helping us understand the link between CO2 and the climate. But why do we still need to go there now?
This area here, West Antarctica, during the last interglacial, this was probably one of the sources of the sea level rise, the 6 metres of sea level rise that was observed during that period, that warm period, 120,000 years ago. As the climate warms towards the late century, we're expecting increased flow from this area, which may add to sea level rise. So it's quite critical that we look at the surface mass balance and how fast the ice sheet is flowing in this area to try to understand how much ice can make its way into the ocean and add to sea level rise by the end of the century.
What are you going back to Antarctica to do now? What comes next for you? Are you based in the lab for the next couple of years, or will you be going back out on the ice?
No, I'm going back out on the ice next year. I'm particularly interested in an area called the Pine Island Glacial Basin. It's an area where, from satellites, it looks like the surface elevation of the ice is gradually lowering. We're not really sure whether this is because the ice has begun to accelerate towards the ocean, or whether it's a change in accumulation rate. I'll bring those back to the lab here, and what I'll be looking for is any evidence of a change in accumulation rate. If there's no change in accumulation rate and the surface is really starting to lower, then we can conclude that the ice is probably, the mass balance is moving towards ice being taken out to the ocean and melting.
Shackleton and Scott were heroes of yours. So do you love being out on the ice?
Yes, I mean, to me that's what the whole point of the job is. Yes, I'm also involved in an exciting type of science, climate change. It's particularly exciting, it's particularly topical. But the thing is, I get out onto the ice, I'm able to be like one of my hero explorers from my youth, and there I'm experiencing the same sort of conditions that they're experiencing. Our equipment has changed to the better over the years, but fundamentally the climate and the weather of Antarctica is still the same. It's still a tough place to work.